A European consortium has managed to guide lightning using a high-power laser installed at the top of Mount Säntis in Switzerland. Forest fires, power cuts, and damaged infrastructure. Lightning fascinates and destroys in equal measure, causing as many as 24,000 deaths a year worldwide, not to mention widespread destruction. Even today, the lightning rod invented by Benjamin Franklin is the best form of protection. And yet, these rods do not always provide optimal protection for sensitive sites. A European consortium consisting of the University of Geneva, École Polytechnique Paris, EPFL, HESSO, and the Trump Scientific Lasers MUNIGE has developed a promising alternative, the laser lightning rod or LLR. After testing the LLR on the summit of Säntis in Switzerland, the researchers now have proof of its feasibility. The rod can deflect lightning over several dozen meters even in poor weather. The results of this research are published in the journal Nature Photonics. Lightning is one of the most extreme natural phenomena. An abrupt electrostatic discharge of millions of volts and hundreds of thousands of amperes, lightning can be observed in a single cloud, between several clouds, between a cloud and the ground, and vice versa. As fascinating as it is destructive, lightning is responsible for up to 24,000 deaths a year. From power cuts and forest fires to damaged infrastructure, it also causes extensive devastation totaling several $billion. Lightning protection devices have changed a little since 1752 when Benjamin Franklin invented the lightning rod, a pointed conductive mast made of metal connected to the ground. The traditional rod is, to this day, still the most effective form of external protection. It protects a surface with a radius that is more or less equal to its height. So, a 10 meters high rod will secure an area with a 10-meter radius. However, since the height of the mast is not limitlessly extendable, it is not an optimal system for protecting sensitive sites over a wide area, such as an airport, wind farm, or nuclear power plant. A European consortium has been working on a device known as the laser lightning rod (LLR). By generating channels of ionized air, the LLR was used to guide lightning along its beam. Extending upwards from a traditional lightning rod, it could increase its height virtually as well as the surface of the area it is protecting. When very high power laser pulses are emitted into the atmosphere, filaments of very intense light form inside the beam. These filaments ionize the nitrogen and oxygen molecules in the air, which then release electrons that are free to move. This ionized air, called plasma, becomes an electrical conductor. The LLR project meant that a new laser had to be developed with an average power of 1 kilowatt, 1 joule per pulse, and a duration per pulse of 1 picosecond. The rod is 1.5 meters wide, 8 meters long, and weighs more than 3 tons. This terawatt laser was tested on the summit of Säntis to observe lightning. It was focused above a 124 meters transmitter tower belonging to the telecommunications provider Swisscom, which was equipped with a traditional lightning rod. This is one of the structures most affected by lightning in Europe. The laser was activated every time storm activity was forecast between June and September 2021. The area had to be close to air traffic in advance. The researchers compared the data collected when the laser filament was produced above the tower and when the tower was struck naturally by lightning. It took almost a year to analyze the colossal amount of data collected. This analysis now shows that the LLR laser can guide lightning effectively. From the first lightning event using the laser, the researchers found that the discharge could follow the beam for nearly 60 meters before reaching the tower, meaning that it increased the radius of the protection surface from 120 meters to 180 meters. The data analysis also demonstrates that the LLR, unlike other lasers, works even in difficult weather conditions such as fog, which can stop the beam, since it literally pierces the clouds. This outcome had previously only been observed in the laboratory. The next step for the consortium will be to increase the height of the laser's action even further. The long-term objective includes using the LLR to extend a 10 meters lightning rod by 500 meters.